Welcome to the exciting world of the Airspeeder EXA Grand Prix, where technology and racing merge to create a thrilling future. As we venture into the high-tech world of electric flying car racing, we begin in the bustling pit area, where software engineers are hard at work. The clattering of keys and the soft hum of computers being fine-tuned to perfection create an atmosphere of intense focus. The pit crews, running through lines of code, work diligently to ensure that the racing supercomputers are operating smoothly, ready to calculate every twist, turn, and speed boost. And of course, the drone racing area, where the pilots gear up with their state-of-the-art controls and gamer gloves. These skilled drone pilots are now ready to race their powerful machines through a high-speed course. Meanwhile, sleek, futuristic racing drones await competition. With their aerodynamic designs and electric power systems, these vehicles are a glimpse of the future of transportation. As the race countdown begins, the energy at the racetrack is palpable. And now, the race is underway. The flying cars roar into action. The future of transportation is here. It's fast, furious, and filled with endless possibilities. Hey there, I'm Graham Class, and this is Technically Speaking, an Intel podcast. The show is dedicated to highlighting the way technology is revolutionizing the way we live, work, and move. In every episode, we'll connect with innovators in areas like artificial intelligence to better understand the human-centered technology they've developed. Advanced technology has always been presented to us in ideas of the future, with iconic scenes from movies and TV like Blade Runner, The Fifth Element, Star Trek, and The Jetsons. Flying cars have always been a part of our vision of what the future could look like. What if that future is not as far away as we think? There have been several iterations of flying vehicles over the years, and there is a newer version that has been branded as the F1 of flying cars. The Airspeeder EXA is a remotely piloted, electric, vertical takeoff and landing racing series. The EXA series was announced in November 2021, and the first races were held in 2022 in South Australia. The EXA series is a development program for the Airspeeder Grand Prix races, which are planned for 2024. But my guests today are the real experts in this technology. Joining me now is Peter Kerney. Hailing from Sydney, Australia, Peter is an enterprise solutions architect for Intel, where he works to find interesting integrations between AI and the business world, further expanding the Internet of Things pipeline. With over 20 years of software engineering experience, Peter joined Intel in 2001 and has risen through the ranks with his dedication to finding end-user solutions that propel technological advancements and making tools accessible to business owners and other stakeholders. Welcome, Peter.
Thanks.
Also here with us is co-founder and the Chief Commercial Officer of Airspeeder, Jack Withinshaw. Airspeeder is an electric hydro-powered flying car racing series set to begin competitions in 2024. Before joining Airspeeder, Jack was an executive in the aeronautics field, as well as a commercial director and consultant for various tech companies. As a leader in sales and business development, he has been responsible for spearheading commercial campaigns in Australia and the UK. In his current role with Airspeeder, he culminates his expertise in aeronautics, sales, and business development with a passion for sports and new media. Welcome to the show, Jack.
Thank you for having me.
Peter, I want to start with a brief discussion on the Internet of Things. In fact, we have heard this being mentioned previously in our podcast. So could you explain in your words what Internet of Things means?
Yeah, sure. As we're seeing lots of business use cases for how do we make efficient infrastructure, how do we control energy grids, we need to instrument this infrastructure. So you put a whole bunch of things connecting and monitoring everything, and then you get the data and the information back from those things into a central platform, massage it, analyze it, look for trends, and then make intelligent decisions on what could be going on in that infrastructure. And as we've seen, there's been all sorts of different numbers, but I've seen numbers as high as 50 billion connected devices. Yeah, like you just look at your own router at home. I've got probably 50 to 100 things connected to my router. But I guess I'm a tech guy, so that's part of the job.
I wonder if your toaster's connected to it.
Nah, toaster's not.
And What are some of the, I guess, enterprise level examples that you could give where companies are using this information to get that competitive advantage or to provide better products and services?
Yeah, well, we've certainly seen a lot of things in agriculture. That's an obvious one where people are trying to get better crop yields, better quality product in order to achieve competitive advantage. Certainly, as I mentioned, the energy sector. So looking at power plants and gas plants, a lot of those things are based around not only production quality, but also safety aspects, making sure that nothing's going to go wrong in that gas processing plant. Pretty important thing.
And how do you see AI and the techniques that's now coming up fitting into the Internet of Pipelines ecosystem?
AI is really an umbrella term. So it encompasses like traditional machine learning and traditional data analytics pipelines as well. And so we do see a lot of things, especially at Intel, a lot of our customers in the manufacturing sector, they're using AI techniques for analyzing vibration in machines to do preemptive failure analysis, to understand when bearings are going to go, or using new video techniques to look for quality assurance, QA use cases, to make sure components have been mounted properly on circuit boards using vision systems. And that's an AI technique, video analytics now.
Okay. And is there any initiatives going on, particularly around the transportation and air travel industry at Intel?
Well, the relationship with Airspeeder is still very new and in its infancy. So we're still working out where the best places to engage are. But Intel is doing a lot of engagement in the avionics space. So looking at real-time systems, safety critical systems, working with some organizations around the future of avionics, which does involve a lot of AI use cases for collision avoidance, safety systems, traffic monitoring and flow and control. So lots of AI use cases coming down in the avionics sector.
Okay. And before I get Jack involved, just maybe a bit of the background story about how you two met.
Well, I got engaged secondhand, I guess, in the project. One of our account executives, Mr. Andrew Ridley, met Jack, I believe, and started a conversation. And Andrew's started talking about the kinds of things Intel does, and we saw some very useful alignment with a lot of the technologies and the things Intel is working on and how they could be applicable to Airspeeder and to Alauda Aeronautics.
So, Jack, I'd like to get your story about what drew you to forming this company, Airspeeder.
Sure. Well, we started back in 2019, but the idea is it's been around for ages. I guess the idea of flying car racing is something we've always had in popular culture for decades now. We talk about Star Wars, Chitty Chitty Bang Bang, Back to the Future. This is the stuff that we were promised. But my co-founder, Matt Pearson, and he first pitched the idea at me up in the hinterlands of Mongolia. We were actually up on the Siberian borders, and I think we're up there for 10 days on horseback riding around. And maybe it was because we were nutritionally deprived and sleep deprived and everything, but the idea made a lot of sense. The simple truth was that every mobility revolution has always started with racing at the forefront of it. And then with the evolution of electric batteries, electric propulsion, as well as the scale up of hobby grade drones now to industrial size, there was a convergence of technology and opportunity, which meant that flying cars could become a reality. But the question was how? And that's where racing came in. As said, it's not a new idea, and maybe it's because we're students of history that it just made a lot more sense for us. But it started there and then with that simple logic, and we've just been following our feet since then.
And for the listeners who are familiar with the hobby drones, could you explain perhaps the major differences between those hobby drones and what you're trying to create with these racing drones?
Absolutely. So drones are becoming increasingly a part of our everyday lives. We're using them for all different situations. There's drones being used in fertilization, in crop scanning. There's drones used in emergency services and construction. What we're doing is a little bit different. They're considerably bigger. Our speeders, as we call them, are about 4.5 meters long. The Mark III, the one that we've been flying at the moment, is fully electric. And they've been designed so that we can put a pilot into these vehicles as well. So they are a drone in the sense that they have a multi-rotor, they're electric propulsion. But when you start to put somebody in them, you start thinking about racing, the line between drones and flying cars becomes quite thin.
Drone racing is such an interesting concept to me. From Formula One and NASCAR, racing circuits have always highlighted the hard work engineers put into giving their cars that extra edge on the track. Now, with these large racing drones, engineers not only have to deal with 2 dimensions, like on a normal racetrack, we now have to consider these flying vehicles in 3 dimensions. This, coupled with the remote piloting aspect, I'm interested to hear more about what other engineering hacks Airspeeder discovered on their journey. And in terms of the structure of how you organise the racing events, maybe you could spend a couple of minutes explaining how that competition is going to work.
Yeah, sure. So there's kind of 2 sides to our entity. We've got Airspeeder the Sport, which is headquartered here in London. And then we've got Alauda Aeronautics, which is in Australia. And that's where we manufacture all the vehicles that compete within the Airspeeder series. So we're building, flying, testing, even crashing these 4.5 meter long speeders in the deserts of South Australia. And they are the vehicles that we are testing, but also we'll start racing this year. And then we've got our first crewed vehicles coming through at the moment. So manned vehicles, which will be piloted and raced in 2024.
Okay, great. And I managed to see some of the videos on YouTube that you have. I'd encourage all of our listeners to have a look at that. Just do a search for Airspeeder just to see some of the trials and tribulations that go through the creation of these machines. You know, as soon as I heard about Airspeeder, I kind of thought of the parallels between, you know, your F1 racing with the technology going on there, and then a few years later downstream it makes its way into the consumer products. Maybe you could share your thoughts around the technology that you're producing, in particular the AI and the Internet of Things devices, and how that could then move into more consumer-based products in the future.
Yeah, sure. So I guess it comes back to the idea of racing being one of the first applications for any new mobility revolution. And that isn't just because there is a setup, a governance, an ability to be able to do it that is, I guess, less rigorous than the commercial space. It also is a great place and space to be able to test new technologies. And motorsport does this famously. So seatbelts, disc brakes, ABS, rear vision mirrors, everything that we have in our everyday car that we drive has at some point bypassed through the white heat of competition at motorsport levels. So it's famous for having quite significant investment in technology, but also a downstream trickle effect into the everyday market. Now, when Pete just talked about how we first met Intel, Andrew obviously was quite attracted to the speeders. They are great looking machines. But I think where Intel and Airspeeder formed a deeper understanding of where this is going, how this is spearheading the industry, is around the infrastructure that is needed to be able to keep these vehicles in the air. So it's not just about the vehicles and the speeders themselves, it's also about the network, the vehicle-to-vehicle communication, how these vehicles are talking to their pit crews, their race crews, that telemetry, that volume of data that needs to be processed at the edge and then sent to the engineers. That really is a microcosm of the cities of the future. It's not just a racetrack. This is the future of what our cities are going to look like.
Perhaps, Peter, if you want to jump in with your thoughts around Intel's role in shaping that future of human mobility.
Yeah, absolutely. And just to sort of touch on what Jack was just talking about, Intel is very critical in 5G infrastructure. We work with all the major telcos, all the major what are called TEMs, telco equipment manufacturers. And so one of the work packages we've got going with Airspeeder and Telstra is around private 5G networks, because of the critical need to not only control the speeders themselves, but this is a sport. It's all about the spectacle and the video, the race. So all of that information and data has to come back from the speeders down into production systems. And so we're definitely looking at that as well. Then we're also talking to them about leveraging some of the work that Intel's been doing with the Olympics around broadcast systems and production systems, some of the stuff we've got going on with F1. So, yeah, there's lots of things we can bring to the Airspeeder sort of racing series, if you like.
Excellent. Can you give us some examples of where it's helped with both performance and the safety of the flying car racing events? Jack?
Yeah, so as a question of safety, the first thing I think about is you need a rigorous network to be able to have the pilot talking to the vehicle. That's the first thing. The next is when you introduce multiple vehicles into the mix, and they have to have a communication with each other as well. So it's something we're just starting with Intel is the next phase of how do these vehicles talk to each other? How can they communicate safely? We want to create something like a force field or a digital bubble around the vehicles so they don't physically touch but can digitally bump. And that will take a lot of processing power to be able to get us to that position.
Peter, maybe you could give a little bit more explanation around some of the tech that's actually on those vehicles in terms of, is it a vision system? What sort of sensors are on there?
Yeah, so we're working on systems for telemetry because, as Jack said, it's really about safety and control and robust communications. If something's going wrong with the speeder, you need to be able to send it a kill pill to just say, stop, drop, power off. So that sort of communication, but it also has to be real time. There's a whole bunch of standards when you start talking about putting people in aircraft. There's standards around airworthiness and safety levels about catastrophic versus hazardous versus minor safety effects. So as we go forward into the design of the Mark IV, which is from the ground up a crewed piloted vehicle, there's a lot of regulatory requirements have to be taken into effect. And so we're definitely looking at leveraging some of that. We're also working with a lot of companies in the US around the future of avionics. What does it look like when you start to have a lot of vehicles in the sky? Situational awareness becomes very important.
So in terms of the use of AI techniques, what's the potential there?
Yeah, obviously we were talking about safety and collision avoidance, and Jack was talking about the virtual bubble. The speed these things are projected to go at, you really need to be using AI techniques to say, what is the likelihood that that vehicle is going to be in that position that I'm going to be in about a quarter of a second? Because I race toy aeroplanes and at 300 kilometres an hour, and they move very quickly and they can cover a lot of ground in very short periods of time. So real-time systems and real-time AI and analytics is going to be extremely important for the safety aspects of this sport.
It only makes sense that such a technologically savvy sport would use AI to configure some sort of safety precautions for it. Not only do the sensors and AI number crunching help with safely piloting the drones, but it can also monitor the power consumption of these racing vehicles. With racing becoming more conscious of its environmental impact, I do wonder how Airspeeder plans to implement AI to better monitor its carbon emissions. What's some of the things that Intel are doing to try and reduce the environmental impacts for, the data processing and data collecting?
So last year, Intel was voted by Barron's as being the number one sustainable company. So we take sustainability very seriously at Intel. Our products are produced sustainably. We have a lot of initiatives around green energy, around hazardous materials, around water recycling in our manufacturing plants. So we'd say the fourth generation Xeon is the world's most sustainable processor. And so it's got a lot of technology built into the processor to accelerate these next generation of workloads such as AI. So reducing the amount of energy used for AI starts at the processor.
And how do you see Airspeeder reducing environmental impacts?
So what we wanted to do is do something that motorsports hasn't done in the past. So we don't need physical tarmac. We don't need tracks. We can race and set up in remote locations. We want to champion electric mobility. And we want to be able to have small amounts of crew and guests on site so we don't create a huge footprint for these races, yet be able to show it and globally broadcast it, have people experience it in their living room, start playing it in esports and start to enjoy it without having too much of an impact on the ground. We're really encouraging kind of sustainability throughout the whole ecosystem.
And perhaps you could just describe for the audience, what do these tracks actually look like?
So for the pilots, at the moment, because they're racing in the uncrewed vehicles, the EXA series, the pilot is seeing an augmented reality track in their remote or ground cockpit. So the pilots are in a cockpit on the ground, vehicles are flying in the air, and through their screen, we've implanted an augmented reality track, which is mapped in Unreal Engine real time, then put through to the pilot control station. In the future, we are going to bring that into the visors for the pilots themselves in the vehicle. We've designed that track to be challenging for the pilots. It's got numerous turns, it's got sky gates, it's off the ground in varying degrees. So it may be 5, 10, 15 meters. The gates are in different positions. And then with the vehicle out there flying in real time out on the track, there's a camera in the front of it. And that camera feed is passed through to the pilot control station. It's then washed through with an augmented reality track over the top of it. So the pilot is now seeing the real world, say, remote desert with a track in it, and is also now competing against other speeders in real time. So we've come a long way in just a short few years, but we're really excited to say that flying car racing with augmented reality tracks in remote locations is a real thing.
And in terms of the fan experience, watching this remotely, what would they actually see in their broadcast?
So the next step is to take those digital tracks and then bring that into the broadcast world. And we've seen that in sport already, the numerous kind of augmented reality elements that are integrated into sport, but we need to bring that track to broadcast fans. So the challenge is then taking that map and running it through not just the pilot's control stations, but also some of the broadcast feeds, flying drones feeds, and then stitching that all together. The next challenge after that would be, how do we take this to the public that want to watch it live? And that future isn't written yet. So things like HoloLens devices, augmented reality devices, or cross-reality devices, phones being used and held up to see the tracks, giant screens. It's very exciting, but we've got a couple of years before we need to allow the public to see the track as well.
Airspeeder has a unique challenge of blending the physical world of racing with the live streaming esport market. Jack's introspection also highlights a recurrent issue for emerging technology businesses. How can we launch, grow, and scale to a global audience? In Airspeeder's case, the concept of an in-phone course visualization is such a unique way to engage an audience in a familiar and comfortable way. I myself have been guilty of being on my phone while watching a movie, so I see how targeting phones instead of the more traditional TV model could be critical to their success as a brand. So, Jack, what's the typical distance that these races go for?
So our vehicles have a battery life of about 15 to 20 minutes. So that gets us a good couple of laps of a 1.5 kilometer long track before they need to come in for a pit stop. And just like motorsports, they'll come in, we'll take the battery out, put the new one in, and we've got that down to just under a minute, which is where Formula One was in the 80s. So we've got some work to do.
So my son loves video games, and in terms of actually becoming a pilot, do you think some of those skills that the next generation are developing with using video games, would that help with becoming a drone pilot? What training is involved?
The problem we have is we don't know where the next generation of pilots are going to come from. So we've had to kind of try a whole different host of different talent pools for the EXA series, the uncrewed series. So we've got pilots that are drone racing champions. We've got aerial cinematographers. We've got people in the motorsport space like Bruno Senna of Motorsport Royalty, all entering in the EXA series to try out their talents. Then we've also got our crewed craft, the piloted craft. That's actually in its developmental phase at the moment and will be raced in 2024. So like the Mark III, our uncrewed vehicle, it has to go through its test card phases, which is a whole series of incremental technological developments. You may have seen at the beginning of Top Gun when Maverick pushes it to Mark 10. We take it a little bit slower, but just like the Mark III did, where it went through test cards, went into drag racing, went into pursuit racing, and then went to circuit racing, our Mark IV, the crewed vehicle, will be doing the exact same test card path as well. So we're testing that at the moment. We're genuinely just waiting on CASA to give us approval. It's the vehicle's sitting in the shed, as they say. But our first crewed races won't be until next year. Probably in a simple format to start with, but we'll grow into a full-blown circuit race format.
I'm interested to know the evolution of the design and how you're going to go from an uncrewed machine into something with a pilot.
So we started uncrewed first and then said the riskiest element, the human, is what we'll bring in later. The Mark III probably was a little bit more design-led, I'm going to say more form over function. It was beautiful. It showed the world what we think a beautiful flying car could and should look like. Did it fly as well as it should? Maybe not. There's a lot of learnings and modifications that you can quite clearly see between the Mark III and the Mark IV, especially around the aerodynamic packages. And so we've got a lot more lift surfaces and winglets that are attached to the vehicle. But its design has changed, whereas it started with form over function. We're now going the other way where it's a little bit more functionally led. But it is important, and we value design really so that when people look at this, they A, know what it is, and they B, they want to get more involved and they want to understand a little bit more about it.
And get in one and fly it.
Yeah.
And hopefully fly it.
Intel's very big in the high-performance computing sector. So all the engineering, the fluid dynamics, the airflow modeling, the manufacturing and the understanding the stress points on the vehicle as it's flying to help optimize those designs, because everyone knows with electric aircraft, weight is a critical factor in how long these things can fly and how fast they can go. So using high-performance computing techniques to optimize these designs is very important.
So maybe just explain a little bit about the gaming side of things.
Sure. So we've started an esports side to Airspeeder as well. We found it was important to start with a physical race series first, show people that this is real, but then also present a bit of a pathway to have a bit of fun, but also learn a little bit more about flying cars. Our partnership with Saltwater Games has allowed that to come to life. They've launched their demo earlier this year. Some pilots have done their first tournament. But this is exciting for us because we get to see and play with a lot of that data and have a look at that talent that come through and hopefully become airspeeder pilots like your son one day.
One of the final questions is moving from the racing side of things, again, back to the consumer side of the industry. Do you think these sorts of technology and these flying cars would actually help with traffic jams and being able to get around, as we see in Star Wars and all these sci-fi movies? Peter, I'd like to get your thoughts about, what's it going to be for our grandkids?
I'm pretty bad at predicting the future. I'm still working, so obviously my investment skills are not as they should be. So clearly aerial vehicles is, for want of a better phrase, taking off. You can see the investments that are going on in electric cars and flying vehicles, aerial taxis, aerial delivery, just because of the economics and just how many people and the congestion issues that we're facing at the moment. So certainly any investment and any progress in the future of avionics and the future of aerial vehicles is definitely important to get us to that future.
Yeah. Jack, what are your thoughts around sort of consumer commute?
Yeah, we're obviously quite a big fan of the idea of everyone owning a flying car at some stage. We've got to remember that mobility revolutions, when they do happen, they happen very quickly. The horse went out of fashion within 20 years and the Model T came in, the price of an average salary so that everybody could afford it. Fundamentally changed the way that cities were planned and the way we moved around. Now, are flying cars the next version of that? Quite possibly. I think that the sequence has to be right in that we have a playground like racing to drive tech, but also to drive public awareness and acceptance and eventually into adoption for these types of vehicles. So the conditions are there. It's been proven in history that it can happen and will happen quite quickly. Will it happen to flying cars? Who knows? But we predict that it's highly likely. But at the moment, we know that we can go racing and it's a lot of fun. So we'll start with racing. We'll see where we end up.
Hopefully we don't end up in the Fifth Element.
Not too dystopian.
All right, I'll leave it there. And thanks very much to both of you.
Not a problem. Thank you, Graham.
Yep, thanks, Graham.
I would like to thank my guests, Peter Kerney and Jack Withinshaw, for joining me on this episode of Technically Speaking, an Intel podcast. I'm always in awe of entrepreneurs and innovators who dive into the realm of the unknown to carve out new spaces and industries. This conversation was truly enlightening, especially hearing Jack's journey in launching Airspeeder and his ambitious visions for flying cars. Jack has a unique way of drawing wisdom from history, tracing from the era of the Model T Ford to the advent of airliner jets and gleaning insights on making personal flying vehicles a reality. Often there's a perception that global organizations like Intel are solely focused on partnering with other large-scale enterprises. So it's refreshing to learn that Intel is extending a supportive hand to startups, offering genuine engineering support and guidance. Peter's thoughts on Intel's partnership with Airspeeder was reassuring. It sends a positive signal to other enterprises, regardless of their size, that the team at Intel is approachable and ready to assist in developing their technological roadmap. At our core, we humans are social beings, a trait ingrained in us for millennia. We're innately driven to connect with one another, nurturing relationships with family, friends, and peers. As we saw with the advent of planes, trains, and automobiles, all of these advancements allowed us to live apart, but also remain close to those we love. The thought of a future where my grandkids, or perhaps great-grandkids, could be maneuvering flying cars is scary, but also exciting. They could be living anywhere in the world, but never truly far from home. The innovative strides by Jack and Peter are not just about ushering in a futuristic mode of transport, but also about fostering a sense of closeness and enhanced connectivity in the society of tomorrow. I'm eager to see how the dream of flying cars turn into a tangible reality, bridging distances and knitting us closer. Please join us on Tuesday, December 12th for the next episode of Technically Speaking, an Intel podcast. Technically Speaking was produced by Ruby Studios from iHeartRadio in partnership with Intel and hosted by me, Graham Class. Our executive producer is Molly Sosha, our EP of post-production is James Foster, and our supervising producer is Nakia Swinton. This episode was edited by Ciara Spreen and written and produced by Tyree Rush.